All right, class, I'm out again today. I have meetings all day, so I'm not even in the building. If you do have questions over this stuff, just bring them to class on Wednesday. We'll go through all this stuff, and we'll still take a quiz on this stuff on Friday. But once again, you guys are going to be able to use your notes. You guys are going to be able to help each other. Just try to learn this material. We're trying to get through this stuff within the next couple of weeks and take our test over it. But this is going to be all derivatives of log functions. So we're going to start out with a couple examples, just how it's going to look, and then I'll actually go through some real stuff with us. All right. So the first one is this function, where it is a logarithm. It's got a base. The a is actually a number. It could be a base 2, 3, 4, or 5, and then there's a function inside of it. So what we're going to eventually do with this is we will have to use chain rule. Right now the function is x. When I do take the derivative of x, it just becomes 1, so it really doesn't change anything. I'll show you how that derivative is going to look. All right, the next one is going to be the natural log of x. Once again, we're going to take the derivative of the natural log function, and then we'll take the derivative of the function inside. So this is going to be chain rule as well. And then the last one is a number, a raised to an exponent. And that could, once again, be our chain rule, all right? So the function as the exponent might not be x. It could be x squared. You're going to have to take the derivative of x squared, all right, because that's a quadratic function. You have two functions within each other. Whenever you see multiple functions written inside of themselves, that becomes a chain rule problem, all right? So we're going to go back to the front. The y equals log, and then there's an a on the bottom, the base, and then we're taking that of some sort of function. So in this case, it's going to be x. All right, like I said, it can change. This is going to be an automatic chain rule. So the derivative of this is 1 over the natural log of your base, whatever that is. In this case, it's a. And you're going to multiply that by your function, which in this case, your inside function is going to be x. That doesn't change. All right, when I go through a couple examples of this, chain rule says you will have to take the derivative of that function. The derivative of x is 1, so I don't have to change anything with this. All right. We're going to come over to the middle function. You'll see how that works when we go through some more examples. All right, the natural log of x, when we take the derivative of that, is 1 over your inside function. All right, once again, your inside function could be x squared. It could be 3x plus 1. It could be square root of x. If that's the case, you do need to take the derivative of that inside function as well. The derivative of this inside function is 1, so I don't change anything with it, so it just becomes 1 over my inside function. Right? Now we're going to go over to y equaling a to the x power. Remember, a is going to be a number. It could be 2, 3, 4, 5, 6, whatever it wants to be. But whenever we take the derivative, we keep it the same. It actually becomes a to the x, stays a to the x, and then we multiply it by the natural log of whatever that value is. So if the a value is replaced with the 2, we're multiplying by the natural log of 2. And then we still have to multiply by the derivative of that function in the exponent. So it's x inside the exponent. The derivative of x is still 1, so I'm not going to multiply it by anything else. Right? You'll see how this stuff works when we move on. Right? The other one that we still have learned is e to the x, and the derivative of e to the x is just e to the x. All right? So that right now, that is our examples of what we've been working, what we're going to work with for today. So these are, 4 different functions. 3 of them are new. One is one that we've known already. But I'm going to show you examples as to how to work with this stuff, and then I'm going to have you guys take out worksheet 3.7. I'm going to go through some problems of that, and when we're done with those problems, it's your responsibility to finish up 3.7 as well. All right, so we're going to work on our next page. So hopefully you guys have taken this stuff down, written it down. If at any point you need to pause, just press the pause, just pause, and then so people can write stuff down. All right, but hopefully you guys can get the hang of that. All right, next part, some examples. All right, so I'm going to start out with this function, and we're going to start with the natural log function. My inside function now becomes x cubed plus 1. This is where the chain rule is going to come into play. All right, another example is going to be the natural log of sine of x. So once again, it's changed. It's not x. It's a new function. It's the sine of x. So this is going to have to once again be chain rule. All right, so I'm going to work with my first one, which is the natural log of x cubed plus 1. The derivative of the natural log is 1 over your inside function, so I'm going to keep it x cubed plus 1. But now I have to take the derivative of my inside function. That's my chain rule. The derivative of x cubed plus 1 becomes 3x squared. All right? And you can see that I'm writing that down. It's going to be your chain rule. So that's the derivative. So Natural log is 1 over the inside function. Multiply it by the derivative of that inside function. All I'm going to do is do some rewriting. I can rewrite this as 3x squared on the top of my fraction, and then x cubed plus 1 on the bottom of my fraction. So that's it. That's that derivative. That's natural log derivative. We're going to do the same thing for the next one. All right, so if you guys need to take a second here, pause the video, write that down, and then start it up again. All right, next function though, y equals natural log of sine x. So same idea, we're going to take the derivative of the natural log function, which is 1 over your inside function. All right, this is chain rule again. All right, 1 over my inside function, which is 1 over sine x. Now I have to take the derivative of my inside function. The derivative of sine x is going to be cosine x. All right, so now at this point what I can do is go ahead and multiply my two fractions together. The derivative is going to be cosine x divided by sine x. Now at that point you can stop. If you do know what the cosine divided by sine is, you can go one step further. You can actually rewrite that as cotangent of x. All right, so there's some examples right there using our natural log function, taking derivatives of natural logs. All right, but like I said, it's the same thing over and over and over again. 1 over your inside function multiplied by the derivative of that inside function. All right, so start to take a look. Hey, it's a natural log function. Oh, I got an x cubed function inside of it. Or this one is natural log. I got a sine function inside of it as well. All right, so you can do multiple chain rules as well. All right, so think about all the ways that we have taken derivatives. All right, so the next page, if you need to take it, once again, pause the video, write the stuff down. Next page for examples. All right, we're going to be taking y equals the square root of the natural log of x. All right, this is going to be chain rule once again. I'm going to rewrite this first. So we should know, hey, it's a square root function. I want to be able to write stuff as x to the 1/2 power. This has to be chain rule because we got the outside function is the square root function. Inside function is my natural log function, and then even further inside of that is my function x. So this is going to be chain rule 3 times. Right? So we're going to start out with my outside function, which is the 1/2. So I'm going to take the 1/2, leave natural log of x by itself, and then you're going to go ahead and multiply or raise it to the negative 1/2 power. So that's my outside function. I just took the derivative of the 1/2. Now I'm going to multiply it by my inside function, the derivative of my inside function, which is natural log of x. Well, the derivative of natural log of x is 1 divided by that inside part. I can go one step further and take the derivative of x. That's my triple chain rule. But the derivative of x is just 1, so I'm not really going to write anything like that. All right, so this is the derivative using our chain rule. Next part is to go ahead and start rewriting stuff. So I'm going to rewrite that first part as a fraction. All right, you can see that I just took the negative exponent, brought it down to the fraction with the 1/2. So I got 1 over 2 times the natural log of x being raised to the 1/2 exponent, multiplying that by 1 over x. All right, so we end up getting two fractions being multiplied to each other, multiply the two fractions together, I can multiply the 2 and the x together. And that's my final answer for my derivative. Once again, you need to take a pause, all right, but I'm going to keep moving on to the next page. We've got a couple more pages to go. All right, more exponents. Now, this one is going to be natural log. All right, so I've got the natural log, or not the natural log, I'm sorry, log base 7 of an inside function. My inside function is x squared plus 1. This is automatic chain rule. All right, no matter what, it's going to have to be chain rule. All right, so the way you start it out is you're going to take 1, divide it by the natural log of your base. Your base is 7. You're going to multiply it by your inside function, which you're not changing. It's x squared plus 1. So that's the fraction part. 1 divided by the natural log of whatever your base was, multiplied by your inside function, which is x squared plus 1. Now, you still have to do chain rule. That was the log. That's the derivative of the log. You need to take the derivative of x squared plus 1. So the derivative of x squared plus 1 is just 2x. Now at this point, all you need to do, you can see that I'm writing up there, hey, it's chain rule. Kind of late on that one, Raphi. All right, go ahead and bring these two fractions together. The 2x is going to go to the top of the fraction. I'm going to rewrite this a little differently. I'm going to put the x squared plus 1 in front of the natural log of 7, just so I can see that they're two separate terms. That x squared plus 1, if you keep it at the end, it might look like it's part of the natural log function. It's not. It's separate. So I always like to put that inside up front. All right, so that's once again chain rule. You take the derivative of your log, take the derivative of your inside function, and there you go. We're going to do another one with our log function. we're going to do, or I'm sorry, not log function. It's going to be 10 raised to the x power. So this is your this is your a to the x that we did at the very beginning. All right. When you take the derivative of a to the x, you're going to keep it the same. So in this case, it's 10 to the x. I'm going to keep it as 10 to the x. I'm going to multiply it by the natural log of whatever my base is, and my base is 10. I can go one step further and multiply it by the derivative of x, which is just 1. So we're done with that problem. All right, this is one where it is going to be chain rule. All right, so I have 4 as my base, and my sine function is my inside function. That's my exponent. So I'm going to take the derivative of my base first. Once again, guys, if you need to take a pause, just pause the button. Just pause the video. All right, but I'm going to take the derivative of my outside function, which is that base, the base 4, and then my inside function is going to be my exponent. So start it out like you normally would. 4 raised to your exponent, that doesn't change. Multiply it by the natural log of your base. Now, you still have to take the derivative of your exponent. The derivative of sine of x is cosine x. And I would finish it right there. That's done. That's completed. Right? So pause right now if you need to. Write this stuff down. I know I'm kind of going through this fast, but this is the good thing about videos is that you can pause and restart and do whatever you need. All right. Next page. Now I want you to take out worksheet 3.7. I'm going to go through a couple problems with you guys. All right. So if you need, pause, look through your packet, just say 3.7. I'm going to start with number 5. All right, number 5 is y is equal to xe squared minus e to the x. Now, a lot of people might want to think that, oh, it's x times e squared. That's product rule. It's not product rule. It's e squared. E is a number. You're squaring a number. It's x times a number. So this is just going to be take the derivative of your first part, which is, it would be the same thing as if it was 7x. The derivative of 7x is 7. So when we take the derivative of x times e squared, it becomes e squared. That's your number. All right, minus the derivative of e to the x, which is just e to the x. So that one, finished, completed. All right, so you got to be careful, look carefully as to where the variables are located. If there was a variable in the exponent with that e, then you would have had to have done product rule, but it wasn't. It was a number. All right, it was e squared. All right. Next problem that I want to go through is number 9. Number 9 is y is equal to 3 raised to the cosecant of x. You're going to start it out like what we just did. I did 4 sine of x. 4 raised to the sine of x is the same concept. We're going to go ahead and take the derivative of your base first, which it stays the same, 3 raised to the cosecant of x. Multiply it by the natural log of your base. Now this is your chain rule because you still have to take the derivative of cosecant of x. Derivative of cosecant x is negative cosecant x cotangent x. So the only thing that I could do with this problem at this point is take that negative, I'll put it up front. And that's really, if you don't want to do that, you don't have to. I just do that because I like to see the negatives up front. All right, just so I know that this whole derivative actually is going to be negative. Right. Now some of you are like, well, why do we have to do this stuff? Remember, we're taking derivatives. Derivatives give us information. Derivatives give us slope. Basically, if you would have graphed 3 raised to the cosecant of x and took a bunch of slopes all over that curve, this derivative function would give us every single slope at every single point. Right. So if you need to pause, write that stuff down. I'm going to move on to the next page. I want you guys to look at number 12. Right. With number 12, you got the natural log, but that is being squared. This is automatic chain rule. Outside function, squared. Inside function, natural log. All right, so we're going to use our chain rule. So take the derivative of your outside function, drop the exponent, subtract it by 1. Now multiply it by the derivative of your inside function. Derivative of inside function is 1 over x. You could go one step further and multiply by the derivative of x. But remember, the derivative of x is just 1. So I don't need to do that. If it was x squared inside, yeah, I'm going to have to take care of that. But not at this point. All right, what we have are 2 fractions being multiplied to each other. Multiply your tops, multiply your bottoms, and you're done. Same thing. Hey, pause the video, write this stuff down. If not, we're going to go ahead and move on to our last problem. Last problem is going to be number 15. All right, with number 15, we have x, natural log of x, and then we're subtracting x. Now, you should notice that's x times the natural log of x. That automatically is going to have to be your product rule. All right, so when we start taking our derivative, I'll take my first, multiply it by the derivative of my natural log, which is 1 over x, plus, I'm an idiot, I wrote a minus, don't write that down, write it as a plus, I'll fix it later in the video, make sure you write it as a plus, plus your second, natural log of x, times the derivative of your first, which is just 1. Now, that right there was your product rule. All of that stuff was x times natural log of x. That's the derivative of that. Of course, at the end, we were still subtracting x, so we have to subtract the derivative of x, which is just 1. All right, now all I'm going to do is I'm going to start multiplying some stuff together. X times 1 over x is x over x. And then my plus, I don't know why I wrote the minus, plus the natural log of x times 1 is just the natural log of x. We're subtracting 1. All right, x divided by x is 1. This is where I start to change it. You'll see I'm an idiot. I don't know why it should have been all pluses the whole way through. So when you start to combine like terms here, the 1 minus 1 actually is gone. You're just left with the natural log of x. So you started with that original function, x natural log of x minus x. When you took the derivative, you just ended up getting the natural log of x. Okay. So at this point, what I want you guys to do is, oh, we got one more problem. Whoops. Let's go through one more. All right, let's go through number 18. So y is equal to log base 2 of 3x plus 1. All right, this is going to be chain rule. We're going to start out by taking 1 over the natural log of my base, which is 2. Multiply it by your inside function, which is 3x plus 1. Multiply that, this is chain rule, this is where it comes in, multiply it by the derivative of 3x plus 1. You have two functions. You got the log function and you got the 3x plus 1. The derivative of 3x plus 1 is just 3. All I'm going to do is do some rewriting. Put the 3 on the top of your fraction. Once again, I like to put the 3x plus 1 in front and then write the natural log of 2 afterwards. That way I show that they're kind of separated, they're different from each other. All right, but that's it. So this is on worksheet 3.7. We did a lot of them. I want you guys to finish working on 3.7. Take a look into Schoology. I know I'm going to have you guys submit one of the worksheets. It might be 3.7. It might be the one that we're going to work on in class on Wednesday. So I'm not 100% sure. But bring your questions on Wednesday. Also, we'll talk about that IXL hiccup that we had on Monday. Thank you for bringing that to my attention. But we'll talk about that stuff. You know, technology, it has issues. And my main thing was I wanted you guys to just practice taking derivatives. And I think the technology got in the way with that. So that's my fault. I'll try and be a little more careful with that in the future. But come Wednesday, bring questions, and we'll talk about that IXL stuff. All right? And make sure that you're getting your assignments done. We will be taking another quiz over this type of stuff on Friday.